So now we need to create a collider that goes between these dots so that it actually makes one of these things expand the entire length. So we're going to create a new method that's going to deal with that. So we're going to basically calculate where the center of these two is going to be, and it's going to scale it based on how far apart these dots are. So we're going to take this collider that we have, our wall, and then these two vectors, A and B, and figure out the distance between them. First, it's going to be void, so it's not going to return anything, and then fit collider between. I can put it inside or outside of any of these that I want. I think I'm just going to put it down here at the end. Fill collider between. It's going to take a collider 2D and two vector 2s. A vector 2, which I'm going to name A, and a vector 2, which I'm going to name B. Oh, I don't need those spare braces. So now we're going to calculate the center position. We're going to set the transform position to be the center. So we're basically going to find the average of the two. That's what this formula here is doing. And set it to be our collider's position. So co, which is our collider, dot transform, dot position is equal to A plus B minus A times 0.5. And this is a float, so we have to put the f after it. All right, so now that we have this thing, now we need to scale this thing horizontally or vertically so that it fills up the whole space. So we're going to grab a distance between the two, A and B, and then figure out if we need to scale on the x, so if the x's are not the same, or if we're going to scale on the y position. So float distance is going to be vector2 dot distance. This is a built-in method in vector 2s. Between A and B. And then we're going to check to see if the two match. So if a dot x exclamation equals means not equal to. So this, instead of using two equal signs to say they are the same, if you use exclamation equals, that means they are not equal to each other. Then we're going to set our local scale equal to a new vector 2 with these two values. So our collider dot transform dot local scale is equal to a vector 2, vector 2. In the parentheses, you do the distance in the x, if they're not the same, and a 1 in the y, or vice versa in the other direction. Oh, I forgot the new keyword. A new vector 2 in that direction. Else the transform scale is going to be a new vector 2 where 1 is going to be in the x position and we're going to scale in the y. Now notice I put the braces in here. They don't do that in the example because there's only one command in the if statement. By default, if you only have one command, you technically don't need the braces. I tend to always put them in though, because then if I ever need to add anything else to my if or else statements, I don't need to worry about adding the braces in. Because if I don't and forget, the if statement would only apply to one of these commands and not anything else after that. So I find it's always good practice if you do if or else statements, always put in the braces just in case. Okay, so now that we have this fill collider between function, we actually need to do something with it. So we're going to keep track of the end of the previous wall as well as our current one in order to deal with this fitting of the object between the two. So let's save off a vector 2 of the last wall's end. I'm going to put this up here near this collider. I guess I didn't put an S in. And then in our spawn wall, we need to save off that position before we get down into this creating the gamed object. So this is basically saving where was the XY position of the previous wall before we create a new one. So now, when we finally get to our lovely update function, after we do spawn all these walls, we now need to change the collider to fit between the two. We're going to pass in the wall, the last wall end, and our current position that we're now in. So basically, what is the difference between the previous position and our current one? If it doesn't say which transform position it is, that means whatever the current object is, which is our player in this case. So after we spawn all these walls in our update, fit collider between. Our wall, last wall end, transform position. Oop, did I say fit or fill? Fit. And there's an S in transform. There we go. So now when we press play, in theory, these things should be right on top of one another. It looks like it didn't create the wall at the beginning, so I need to make sure I go fix that real quick. There we go. I forgot to include a spawn wall in the start method so that we start one off at the very beginning. So we need to call spawn wall here as well. Otherwise, Unity complains that there's a null reference to that thing at the beginning. Make sure I save it, and away we go. Now you may have noticed that when we run this, notice it doesn't quite match up at the corners. So we're going to have to fix that real quick. So we're just going to add 1 to this distance to make it match more closely so that you don't have these extra corners that aren't there. So the only thing we're going to alter is in the scaling, just make it slightly larger. So down here in our fit collider between, not fill collider between, I'm going to add 1 to this distance and add 1 to this distance. The spaces between the pluses don't matter, by the way. It's up to you as to how you want to see that. All right. And it looks like we're good on our first player.